Okay, so on this one, section 4.5, we're going to have a quiz toward the end of class Thursday, but it'll be at the very end of class. And again, if you did want to come in early on Thursday, let me turn. Okay, so for number 3, if we have y equal 3 sine 2x, they want us to find the period and the amplitude. Now, it might help on these problems if we go ahead and label. Do you remember this is a and this is sine, so we'll just write sine here instead of cosine, bx minus c. And then if there's a number added onto it, we said that would be a plus d. And the book doesn't really show that in their formula, but then they give you some problems like that, I noticed, to graph later on. So it's like, well, why didn't you put that in that formula? But anyway, so now my amplitude is the a part. So my amplitude here is 3, okay? And so you can just put a equal 3. And the reason I knew is I've labeled it. A is out front. That's the amplitude. If they had given me 2 plus 3 sine 2x, remember the 3 is always going to be, the amplitude is always in front of the trig function. So you may have to rearrange the equation if they try to trick you by adding a vertical shift in. So just know, go find the part that has the trig function. It's the number in front of the trig, you know, the actual trig function, sine or cosine or tangent, whatever it is. Okay. So now the period. The period of sine would normally be 2 pi, and they give us a little formula to find it, 2 pi over b. Do I have a b here in this problem? Is there a number in front of the x? Yeah, there's a 2. So my b is 2. So if I want to figure out the period, I'll divide by b. b is 2. So it's just, oh, the period is pi. That means when I go to graph this thing, here's what, we'll go ahead and practice a little simpler graphs because then they start throwing things at you that aren't so simple, you know, pretty quickly. This amplitude being 3 means instead of the graph going up to 1 and -1 like the basic one we did yesterday did, they're not scooting this thing up and down. If you look at this one, there's not anything added to it. There's a real quick way to graph this. You know how you usually would write 1 and -1 on your graph if you were doing this? Just make this 3 and -3 and you fixed your graph so you don't even have to, you know what I mean? You don't really need to worry about points in between. That's your maximum and your minimum. That's what amplitude does. Tells you how tall it is in each direction, basically. And then, let's see now, the period is pi. Normally, I would have had, since the period is pi, doesn't that mean it's going faster, in this function going faster? Instead of completing a whole run through the whole, you know, up curve, down curve thing, in 2 pi, it's doing in half as much time. So probably what I ought to do is label by, instead of pi halves, I'm going to label by pi over 4, and that's the sheet that I gave you yesterday. It actually has, that's actually how they're counting on there, so it's kind of handy. So I'm just going to go ahead and put those in. That would be pi over 4, 2 pi over 4 would reduce to pi halves, 3 pi over 4, and then pi. If I were to sketch this graph really quickly, I know that sine, do you remember how we said sine starts low and goes up? You could always look at the unit circle and know that the sine of 0 degrees is 0 because it's the y coordinates. You could always look at your unit circle. But you could also go sine starts high and goes up. And it was hitting all those major 1s and 0s at 90 degree or pi half degree intervals, but this time it's going faster because the period is smaller. That's what the 2 in front of the x did, is it cut the period down, makes it go faster. So when instead of going up to 1 at pi halves, it's just going to do it at pi fourths. And so if you kind of see that those are your increments, you go, well, it's going to go up, and then it's going to come down, and when it comes down, it's going to have to go through 0. And then it's going to have to go to -1, so that's going to, or -3 in this case, because it's new amplitude. But you see I'm still thinking like -1 in my mind, and I just switched those numbers on to 3 and -3 so I could graph really quickly. You can play mind games with yourself and make this a whole lot easier. And then it's going to be all the way back up to 0, having gone all the way up and all the way down. And there's my graph of that function. And all I did was play with these numbers here. And then I just thought about, well, if it's going twice as fast, instead of hitting 1 at pi halves, it's going to hit it at halfway in between, which is pi fourths. It's like instead of counting by 90 degrees, we just count by 45 degrees. And we kind of put that basic structure on there and we graphed it. You didn't have to do that there. I think it's just kind of helpful to look at some graphed that are a little simpler before we get into it later on. So over here, we'll just do the basics on this because they're not going to give you anything this hard to graph right off the bat. What is my amplitude here? If I label this, it's A cosine bx minus c. Maybe I label it so I can see everything. What is the A here? 5/2. So my amplitude is 5/2. That means it's going to go up to 5/2 and down to negative 5/2 instead of 1, negative 1. And when I draw my graph, I can play that silly little mind game with me. If I were graphing this one where I put 3 and negative 3 here, I could just put 5/2 and negative 5/2, and it's not like I have to think that hard about it. I just know that's the highest it's going to go and the lowest it's going to go, and I don't worry about the specific numbers so much. Now the period here is 2 pi over b. Is there a b in this problem? Is there a number in front of the x? What if I put a 1 in front of the x? Do you see that they've written it as x over 2, but it's really 1/2 x? So yeah, I do have a b here. It's 1/2. So if I want to find the period, it's going to be 2 pi over a half. So we got another complex fraction to simplify. So you could put 2 pi over 1, that's your numerator, and multiply by the reciprocal of the denominator to get the complex fraction, simplified, and it would be 4 pi. Do you notice our period is longer here? It's going to be more stretched out. It was normally 2 pi, and now it's 4 pi. So when we put a fraction in front of our x, it stretches it out longer horizontally. It just takes longer to go through. So if you think about how would I graph this, actually it wouldn't be that hard to graph this one, even though it looks like it might be. If I were to go, okay, my highest one is 5/2 and my lowest one is negative 5/2, but I'm just going to think about 1 and negative 1 like I, was graphing a simple one. I can just put those numbers there and pretend that's 1 and negative 1 and forget about the amplitude. Normally, on the normal cosine graph, we're counting by 90 degrees. Since our period is 4 pi and 2 pi, doesn't it mean, if you think about it, it's taken twice as long as the normal graph to finish, a whole cycle. So that means instead of counting by 90 degrees, we'd say, well, what's twice 90 degrees? 180 degrees. So I could go, oh, every 180 degrees it's going to hit one of these either highs, lows, or 0. So that means I could count by pi, 2 pi, 3 pi, and 4 pi, and I could easily graph one cycle of this, and I could say, okay, cosine, if you remember from yesterday, it starts on the high mark. It starts on 1 normally, because cosine of 0 would be 1, the x-coordinate would be 1. It's 5/2 here, but that's okay. I can think in terms of 1s and 0 and put that at the high mark, and then it's just it starts high and it goes low. That means it's going to drop. Well, you know what? All I got to do is, when it drops, doesn't it have to go through 0? And then it's going to go down to negative 1, which is negative 5/2 here because of our amplitude change. And it's got to come back up before it hits another high. It goes right back to where it started. So if you think about it, in going from the highs to the lows, there's that intermediate. It's got to pass through 0. So you can kind of just think, oh, there it is. I can graph it really quickly. I could just say, instead of doing the normal graph where I'm counting by the 90-degree marks to hit those major highs, lows, or zeros, I need to count by 180 degrees, which is pi, and I can graph that really quickly. Okay, so all we're supposed to do here is tell the period and amplitude. This is, again, the kind of stuff you're going to do on your quiz by the end of class on Thursday over this section. I'm not going to make you graph on the quiz. It's always just going to be, identify these things like we did in the homework. What is your amplitude here? 2/3, which basically meant that if I'm going to draw my little graph, instead of writing 1 and negative 1, I'm going to write 2/3 and negative 2/3, and I'm just going to think in terms of 1 and negative 1, so I can just ignore that change to the equation. What is my period going to be? What's my b? I need my b to figure out my period. It's 2 pi divided by b. What is b in this case? Pi, yeah. The number in front of the x is pi. So that means 2. Oh, that gets confusing now. These are the ones that are the most confusing to me. That means I'm probably, if you think about it, I'm going to number differently. I'm not even going to number using the pi's anymore. It's going to complete a complete cycle in 2. That's 2 radians. not real helpful because we don't know how to think about that so much. But let's think about this. If you think about it, aren't there 4 values? You start, like with sine, we're going to start low at 0, right? Now, we need to divide this 2 up into 4 parts in order to hit all of our zeros and ones that we got to do. So doesn't sine start low and it goes high? Wouldn't this be like a half here that I'm not even going to label it because it'll be so messy on the iPad, but it would go up to its maximum because its sine starts low, it goes high. Then it's going to drop back down midway at 0. Well, midway, if I've taken this 2 and divided up into 4 parts, like we see has been the pattern with, when we had pi halves pi, 3 pi over 2, and 2 pi on a normal graph, those were our 4 kind of divisions. I'm just going to take 2 and divide it up into 4 parts. It's going to go low down here, which would be like 1.5. I don't even really care what that value is because I just split my area up into 4 parts. And then it will come back up to where it started at 2 and end. That's what it means to have a period of 2 instead of